Good evening, children.
Good evening, ma'am.
Good evening. Good evening,
Good
children.
evening, ma'am.
Good evening. Yeah. So we were doing example 8. We finished with example 8 in the last class. We'll just see that again. So in example 8, we have a point P. Yeah. In example 8, we have a point P which is equidistant from two lines L and M intersecting at the point A. So we have two lines L and M. L and M intersecting at the point A. Two lines L and M intersecting at the point A. And P is a point which is equidistant from the two lines. So I was telling you, these are the two lines. L and M are the two lines. So now P is a point which is equidistant from the two lines. Now, if you have to walk from this point P to the line L, I was telling you that you can walk in different ways. You can walk like this. You can, from the point P, you can reach the line L using this route, using this route, using this route. There are so many routes. It's a line. L is a line. So you can, from the point P, you can reach the line L using so many different routes. So here they say P is equidistant from the lines L and M. So here the distance is the perpendicular distance. When they say equidistance, that distance, which distance are they talking about? They're talking about the perpendicular distance. The perpendicular distance. So from the point P, this is the perpendicular distance from the point P to the line L, to reach the line L. This is the route. This is the perpendicular. This is the route which is perpendicular to L. This route, that is if you walk like this, if you walk like this, let's call this point B. So if you walk along PB, that is that line is perpendicular to the line L. Similarly, from P, draw perpendicular to the line M. From P, draw perpendicular to the line M, call that point C. So to reach the line L from P, you're going to use the route PB. To reach the line M from the point P, you're going to use the route PC. So here it's important that PB is perpendicular to L and PC is also perpendicular to M. And now these two distances are also equal because they're equidistant. P is equidistant from L and M. So not only are these two line segments PB and PC perpendicular to L and M respectively, they're also equal. The distances are also equal. PB is equal to PC. Now we need to show that AP, meaning you'll have to join AP. We need to show that AP bisects the line between them, bisects the angle between them. So this is the angle between them, is between the two lines. Between them meaning between the two lines. See, this is one line, this is the other line. This is the angle between them. This is the angle between them. Meaning, to what does the word them refer to? The lines L and M. So AP bisects the angle between them. Them meaning L and M. So this is the angle between L and M. This is the angle between L and M. You need to prove that AP bisects angle A. This is the angle between the two lines L and M. So you need to prove that AP bisects angle A. So we have numbered the angles 1, 2, 3, 4 like this. This one has 1, this one has 2, this one has 3, and this one has 4. All right. Yeah. So you need to show that angle 1 is equal to angle 2. Angle 1 is equal to angle 2. So straight away, take these two triangles APB and APC. Okay, in triangle APB and APC. Look at the triangles APB and APC. So angle 3 of this triangle is equal to angle 4 of this triangle, 90 degrees. 90 degrees. That is right angle, R. Then you can see that PA is a common hypotenuse. PA is equal to PA. It's the common side. It's also the common hypotenuse. PA is the hypotenuse, which is common to both the, okay, PA is the side, which is common to both the triangles. And it happens to be the hypotenuse in both the triangles. Because you can see that PA is opposite to the right angle. Both the triangles are right triangles. Both APB and APC are right triangles. And which side do we identify as the hypotenuse? The side opposite to the right angle. So clearly AP is the hypotenuse in both the triangles. And it's the common hypotenuse. So H, that makes it H. PA is equal to PA because common hypotenuse. So that is H. And some other side. So we know that PB of this triangle is equal to PC of this triangle because equidistant. PB is equal to PC. So this is given to us. This is given to us. So this is some other side. Right angle, hypotenuse, and some side. So by RHS congruence criterion, these two triangles are congruent to each other. So CPCT, we have angle 1 is equal to angle 2, which means AP bisects the angle between L and M. So I'm stressing on this, that this term equidistant means the perpendicular distance. See, here it is given in the figure, but in the exam, sometimes only the description is given. You'll have to draw the figure. Then if you don't mark this 90 degrees, then you will not be able to show, you will not have information to show that the triangles are congruent. That's why I'm stressing on this. There are so many distances. So which distance you have to consider is the perpendicular distance from P to L and from P to M. And the perpendicular distances are also equal because equidistant. They're also equal. So PB is equal to PC. Also, PB is perpendicular to L. PC is perpendicular to M. Yeah, we finished this in the last class. Now let's continue. All right. So here, triangle ABC. See the figure as I'm reading. Triangle ABC and triangle DBC are two isosceles triangles. So are two isosceles triangles. See, they have the same base BC. The two triangles have a common base BC, which means that is not any of the equal sides. So clearly this side is equal to this side and this side is equal to this side. That is in triangle ABC, AB is equal to AC, and in triangle DBC, DB is equal to DC, because it's given that ABC and DBC are both isosceles triangles on the same base BC. And the vertices are A and D. The vertices are A and D, and both the vertices are on the same side of BC. Why is that given? Why is that given? Because see here, we can have, the common base BC, one isosceles triangle like this, and the other isosceles triangle like this. We saw it in the examples, right? Yeah. So see here, this is a figure where we have two isosceles triangles, APB and AQB. APB is isosceles. It's not directly given it is isosceles here, but when you make the figure later, you realize that it is the two triangles are isosceles. So here we have two triangles, two isosceles triangles, APB and AQB on the same base AB, and the vertices P and Q are on the opposite sides of the common base AB. The description given here is different, but when you finally make the figure with the help of the given information, what do you understand? Okay, so these are two, APB and AQB are two isosceles triangles with a common base AB. So if AB is a common base, that means this side is equal to this side and this side is equal to this side. Now, these two isosceles triangles are on the opposite sides of the common base AB. So how do we put that? The vertices P and Q. The vertices P and Q are on the opposite sides of the common base AB. So in this figure, the vertices P and Q are on the opposite sides of the common base AB. So the figure is like this. So common base, one isosceles triangle like this, the other one like this. The vertices are on the opposite sides of the common base AB. But here we have two isosceles triangles. Here we have two isosceles triangles on the same base BC. So now you have a question. Now that you know the situations, your immediate question in your mind is, okay, on the same base BC, now are the triangles on the same side of BC or on the opposite sides of BC? So that is what is given further. And vertices A and D are on the same side of BC. Because you know that the triangles can be on the opposite sides of the common base or on the same side of the common base. So it's very clearly given here that the triangles are on the same side of the common base. Same base BC, and vertices A and D are on the same side of BC. So same side can be above or below. So same side, can be, you can also draw the diagram like this. You can also draw the diagram like this. Same side can be above or below. Like this also you can draw. But you're comfortable with this, right? We are always comfortable with a triangle upright like this. Just for convenience, we take it like this. You can also draw the figure like this. You can also take the two triangles below BC. Below BC. The proof will be the same. Okay. So let's draw that. So BC is the common base. BC is the common base. The vertices A and D are on the same side of BC. The triangles are called ABC, DBC. ABC. ABC, DBC. Okay, DBC. Now what's given further? So this is equal to this. This is equal to this. What's further given? If AD is extended, AD, so that means you join A and D. Join A and D. If AD is extended to intersect BC at P, so AD, you join AD and you extend it. You extend it to intersect BC at P. It touches BC at P. It touches BC at P. It intersects BC at P. With this information, we'll have to show that, we'll have to show these four results, okay? These four things, 1, 2, 3, and 4. All right. All right, children. So who can tell me without looking into your book? First, we have to show that ABD. See it, ABD, this triangle. This triangle. See, I've already shared the answer slides with you, the answers with you. Kindly don't look into the book and read it for me. Yeah. Tell me, children. How do we show that these two triangles are congruent? We know that this side is equal to this side. Yeah, Krishmika Shri. Krishmika Shri.
Ma'am.
Yes, please try this one.
Yes, ma'am.
Yeah, we have to show that triangle ABD is congruent to triangle ACD. So tell me one side or angle of this triangle is equal to side or angle respectively of this triangle. Start.
Yes, ma'am.
Yeah. No problem. Raja?
Ma'am?
Yeah. Same question.
Ma'am, AD is equal to AD.
Okay.
Because it's common side. Ma'am, then AB is equal to AC.
AB of this triangle is equal to AC of this
AC of
triangle.
this triangle.
Good.
Then BD is equal to DC.
BD is equal to BC. BD is of which triangle?
Ma'am, ADB.
And BC is of?
Ma'am, ACD triangle ACD.
So how do you, Raja, how will you explain this? How do you write these equalities, Raja? Can you write anything? How do you explain what equalities to write here?
No, I can't understand what you are asking.
Okay. No, we have written some equalities here, right?
Yes, ma'am.
See, AD is equal to AD is an equality. AB is equal to AC is an equality.
Yes, ma'am.
Yeah. Now, how do we, what is the criteria for writing these equalities? Okay, I'll tell you one. Now, for example, AB of triangle, AB is a side of ABD. AB is a side of triangle ABD. It is
Yes.
equal to AC, which is the side of the other triangle ACD. So you cannot write two sides of the same triangle. Supposing two sides of the same triangle are equal.
Yes.
You cannot, sorry. Okay, if two sides of the same triangle, supposing for AB, in ABD itself, you have two sides equal. We can't write that, right? You have to write one side of ABD is equal to another side of ACD, correct?
Yes, ma'am.
Yeah, now tell me. So AD of triangle?
AD of triangle ADB
Is equal to?
AD of triangle ADC.
Why? Because it is the
Common side.
common side. Similarly, BD of triangle?
BD of triangle ADB is equal to BC of triangle ACD.
BD is equal to BC, yeah? Is this correct? BD is equal to?
DC, ma'am.
DC, yeah, I think you told me correctly. I didn't write it correctly. Yeah, DC. Sorry, children. DC, not BC. So BD of this triangle is equal to DC. DC is the side of this triangle. Correct.
Yes.
So what's the congruence rule?
SSS, ma'am. SSS congruence.
Yeah, the two triangles are congruent. Very good. So now from this, what are the other results you can derive, Tanishka?
Yes.
Now tell me the order. Okay, order is already there. ABD is congruent to ACD. Now we already have three sides of the first triangle is equal to three sides of the second triangle. So sides already equal. Now tell me about the angles. Okay, tell me about the angles. Now let me mark the angles. Tanishka, I'm marking these angles. 1, 2, 3, 4, 5, and 6. See what I'm marking. I'm marking the three angles of triangle ABD and the three angles of triangle ACD. I have marked the three angles of triangle ABD and the three angles of the triangle ACD. Now that ABD is congruent to ACD, tell me the corresponding angles which are equal. Quick.
Angle 1 is equal to angle 2.
How? CPCT
Ma'am,
is fine, but how do you identify 1 is equal to 2?
Ma'am, since A is the midpoint, it bisects.
No. No. Danya?
Ma'am,
Yeah. Angle 1 is equal to angle 2 is correct. CPCT is the reason. But how do you know that 1 is equal to 2? Why not 1 is equal to 6?
ma'am, because it is in the same side, ma'am.
Ma'am, can I say?
Yes, Madhumita?
Ma'am, it's according to the name of the triangle, ma'am.
Correct. Correct. A of the first triangle is equal to angle A. Angle A of the first triangle is equal to angle A of the second triangle. Which is angle A in the first triangle? Which is angle A in the first triangle? This one, no. Only this one is angle A. Only this portion is angle A. This full thing is not A. In triangle ABD, see this is only, see the triangle separately, ABD triangle separately like this, ABD. See the triangle separately, only this one is A. This A, angle A of the first triangle, only this is A, is equal to, see the second triangle is ACD. ACD, take the triangle separately. Take the triangle separately and see ADC. This is A of the second triangle. See here, A of the first triangle is equal to A of the second triangle. This is A of the first triangle. This is A of the second triangle. When we say A, it is not the whole of angle A. It's not the full angle A. It's not the full angle A. That part of A, which is in the first triangle, is equal to the remaining part of A, which is in the second triangle. So Madhumita is right. A of the first triangle is equal to A of the second triangle. Angle A of the first triangle is equal to angle A of the second triangle. That doesn't mean this whole of angle A is equal to the whole of angle A. No. What part of A is in ABD? Only this part of A is in ABD. See the triangle separately. Detach it from the main figure. See the triangle separately. You have only this part, this much in the first triangle, and you have the remaining in the second triangle. So this angle A is equal to this angle A, CPCT. Now, Tanishka, tell me the other pairs of equal angles. 1 is equal to 2, then
3 is equal to 4, ma'am.
reason?
Since both the sides we have in ABD we have angle 3, ma'am, and in triangle ADC we have angle 4, ma'am. Same side, ma'am.
No, Danya?
Ma'am, it's actually based on the name. So here in the second letter is B. It's not like second letter. So the angle phi of the second letter, I mean the angle B, angle phi of the angle B is equal to 6 of angle 3. Ma'am.
Yeah, that is angle B of the first triangle is equal to angle C of the second triangle, correct?
Yes, ma'am.
Yeah, so which is B of the first triangle? Only this one. This is B of the first triangle, and this is C of the second triangle. Only this whole thing is not B. Okay, this is angle B, but we are not talking about that B. We are talking only about that part of B which is in the first triangle. So this much of B is equal to this much of C. See here, B is equal to C. B is equal to C. Angle B is equal to angle C. So this one, angle 5 is equal to angle 6. And finally, we have D is equal to D. So this is D of the first triangle, and this is D of the second triangle. They are equal. So 3 is equal to 4. So we have these results. If we want, we can use them later. So now that we proved that the two triangles are congruent, we have these results from CPCT. Angle 1 of this triangle is equal to 2 of this triangle. 3 of this triangle is equal to 4 of this triangle. 5 of this triangle is equal to 6 of this triangle. So all this, now that you've proved these two triangles are congruent to each other, you have all these results. You don't have to write them now, but you have to keep in mind that you can use these results if needed. If you want to prove that some other two triangles are congruent and you don't have sufficient information, you can use the results of CPCTC from the congruency of these two triangles. Okay, so for those, if it is not clear, I just want to repeat. See, look at the triangles separately. Look at ABD and ACD separately. This is ABD. This is ABD. Okay, this is ACD. Excuse me. Okay, something like this. Okay, so this is ADB. This is ADC. So we know that AB is equal to AC and BD is equal to DC. And this is the common side. This is the common side. So as you all said, ABD is congruent to ACD by SSS congruence criterion. Now CPCTC, you don't have to write them. But remember that we have these results. Now that these two triangles are congruent, A of this triangle, the first triangle is equal, angle A of the first triangle is equal to angle A of the second triangle. This is angle A of the first triangle. This is angle A of the second triangle. They are equal. That's why we said angle 1 is equal to angle 2. Angle 1 is equal to angle 2. Then angle B is equal to angle C. Angle B of the first triangle, this one, angle B of the first triangle is equal to angle C of the second triangle. That's why we said 3 is equal to 4, whatever the number we gave earlier. Okay, so this 3 is equal to 4. Angle D of the first triangle is equal to angle D of the second triangle. So what is that? Angle D. So this is angle D of the first triangle. This is angle D of the second triangle. So 5 is equal to 6. So that's why we marked this angle 5 is equal to this angle 6. All right. Next, we have to show that I think it should be clear to some of them who did not understand it earlier. Now, next one, we'll have to show that ABP is congruent to ACP. So let's draw them. ABP, see it? ABP, the full triangle. See the main figure. ACP, ABP, ACP, ABP, ACP. Oh, sorry. Yeah, who wants to try this? Sindhu, Sanjay?
Ma'am, can I know?
Yes.
Ma'am, AB is equal to AC common, ma'am. Ma'am,
AB is equal
given, ma'am. AB equals to AC given, ma'am.
Given.
Ma'am, and angle 1 is equal to angle 2 we found in last subdivision, ma'am. First
Correct. Correct. Angle 1 is equal to angle 2. This angle 1 is equal to angle 2. Correct.
AP is common, ma'am. AP equals to AP common, ma'am.
AP is equal to AP common side. AP is equal to AP common side. Correct. So
Yes,
what's the rule?
ma'am.
So this angle 1 is equal to angle 2 is not given. But as Sanjay said, we're using the result from the congruency of the earlier two triangles. Angle 1 is equal to angle 2, CPCTC from the congruency of the earlier two triangles. So we're using that information here. So by SAS rule, the two triangles are congruent. Very good.
Yes,
so now, yeah, tell me the order.
Ma'am, AB equals to AC, ma'am.
ABP is congruent to
ACP, ma'am.
ACP by SAS rule. Very
Yes.
good. Now, what are the other results, Sanjay? We have only two pairs of equal sides, right?
Yes, ma'am.
Yeah, now which is the third?
Ma'am, BP equals to CP, ma'am. CP.
Yeah, see, side BP is equal to the side CP. Side BP is equal to the side CP, CPCTC. Because only two pairs of equal sides we know. So now the third pair is also equal. BP is equal to CP, CPCTC. Yeah, then?
Angle B is equal to angle C, ma'am.
Angle B is equal to angle C. So this is angle B, is equal to, this is angle C. This is angle B. This is angle C. So that means in the main figure, this full angle is equal to this full angle. That we already know because we already know because it's isosceles, right? ABC is isosceles. So this side is equal to this side, which means this whole angle is equal to this whole angle. But anyways, now the triangles are congruent. Angle B is equal to angle C. Next.
Ma'am, angle P is equal to angle P, ma'am.
Angle P is equal to angle P. That is this angle. This angle P is equal to this angle P. So that means in this main figure, this angle is equal to this angle. So the new results are BP is equal to CP, CTC, and this angle is equal to this angle. If you call it 7 and 8, angle 7 is equal to angle 8, CTC. Okay. Yeah. Now I have to use this one. So how many of you have completed writing all this, children, in your classwork? Netra, Danya, Raja, Madhumita. Okay, the others please complete it. Sanjay and Sindhu. Okay. Arjun, Srijana and Krishmika Shri, please find time to complete all this in your tuition notebook.
Yes, ma'am.
Yeah.
Yes, ma'am.
All right. So see here, children, I've marked the angles here. You can see. This is the first proof. This is to prove that ABD is congruent to ACD. Concentrate. ABD. See, I've taken the triangle separately. This one is to prove that ABD is congruent to ACD. This we already finished. Next, ABP, ACP, what we just did. ABP, ACP, what we just did. Okay, next. I told you, this is the question, and this is, I told you, the first two columns have repeated in the next slide. The first two columns have repeated in the next slide. So this is the next proof, the third one, this one, third one. AP bisects angle A as well as angle D. AP bisects angle A as well as angle D. Yeah. Tell me, children. We already know that AP bisects angle A, correct? Because we proved that angle 1 is equal to angle 2. See, we have to show that AP bisects angle A as well as angle D. We already know AP bisects angle A. How do we know that? See, this is AP. This is AP. And this is angle A. We already know that angle 1 is equal to angle 2. Because we proved two triangles are congruent, there itself we got the result angle 1 is equal to angle 2. So AP bisects angle A. So now we have to prove that AP bisects angle D. See here, AP bisects A and D. So we'll have to prove that AP bisects D. This is angle D. So you'll have to prove that angle 3 is equal to angle 4. You have to prove that angle 3 is equal to angle 4. So for that, see, you're not asked to prove that BDP is congruent to CDP. BDP and CDP, you're not asked to prove that they are congruent. BDP and CDP, see the small triangle and the small triangle. You're not asked to prove that they are congruent. But why we are doing it is because we'll have to show that AP bisects angle D. And this is angle D. If you show that angle 3 is equal to angle 4, that means AP bisects angle D. AP bisects angle A because angle 1 is equal to angle 2. Now, if you prove that angle 3 is equal to 4, AP bisects angle D. So how do we prove that 3 is equal to 4? This is one of the ways. You can do it without congruency also. I'll tell you that. Without congruency also you can do it. Now this is using congruency. So take up, where is angle 3? In triangle BDP. Where is angle 4? In triangle CDP. So we take up these two triangles. Why do we take up these two triangles? Because angle 3 is in this triangle, angle 4 is in this triangle. So we take up those two triangles. Okay. Now, BD is equal to DC because the triangle is isosceles. I've shown the triangles here. You can use this. See here, I've taken the triangles BDP and CDP separately. BD is equal to CD because isosceles. BD is equal to CD because it's isosceles. BDC is isosceles. BDC is an isosceles triangle. So we already know that BD is equal to DC. Then BP is equal to CP. We proved that two triangles are congruent no earlier. These two triangles are congruent. So CP, CTC, we have BP is equal to CP. BP is equal to CP. And DP is equal to DP common side. DP is equal to DP common side. See, this side equal to this side we already know because the triangle BDC is isosceles. This one is isosceles. So this side is equal to this side. Then DP is the common side. This DP is the common side. And then BP is equal to CP because we proved that this triangle is congruent to this triangle. So BP is equal to CP, CP, CTC. So SSS rule, these two triangles are congruent. SSS rule. So that's what I've written here. BP is equal to CP, CPCT from congruency of these two triangles. DP is equal to DP common side. And then DB is equal to DC because the triangle DBC is isosceles. So from these results we have by SSS rule, the two triangles are congruent. The two triangles are congruent by SSS rule. So you can see here angle D is equal to angle D. Angle D is equal to angle D. I have told you how to write the order. How to write the order, I've told you. If you take up these two, BP is equal to CP. And the next one is DP, but write as PD is equal to, this is DP, write as PD. I've told you. So it will be BP, PD, BPD, CP, PD, CPD, BPD, CPD, BPD, CPD. To write the order, just take up any two equalities. BP is equal to CP. The next one is DP. That letter which is common is P. Write that first. PD is equal to DP. Write P first. PD. So see a BP, PD. BPD is the first triangle. CPD is the second triangle. BPD, CPD. SSS rule. So angle D is equal to angle D, CP, CTC. So this is the angle D of the first triangle. This is the angle D of the second triangle. Angle D of the first triangle, angle D of the second triangle. So that means angle 3 is equal to angle 4. This is angle 3, this is angle 4. Angle 3 is equal to angle 4. CPCT. So you proved that angle 3 is equal to angle 4. So 1 is equal to 2, we already proved. So 1 is equal to 2 means AP bisects angle A. 3 is equal to 4 means AP bisects angle D. So this means AP bisects angle A and angle D. We already know 1 is equal to 2. So AP bisects angle A. Now 3 is equal to 4. So AP bisects angle D. So from these two, AP bisects A and D. And finally, you'll have to show that AP is the perpendicular bisector of BC. You'll have to show that AP is perpendicular to BC and AP bisects BC. AP is perpendicular to BC and AP bisects BC. See, two things. AP is perpendicular to BC. That means this is AP, this is BC. Perpendicular. You'll have to prove that this angle is 90 degrees. And bisects. AP bisects BC. BC, this is BC. AP bisects BC. That means you should show that BP is equal to CP. So these are the two things we'll have to prove. AP is perpendicular to BC. See here, AP, BC, perpendicular. So you'll have to prove that this angle is 90 degrees. AP bisects BC. This is BC. BC is bisected by AP. BC is bisected. AP bisects what? BC. BC is bisected. So you should prove that BP is equal to CP. BP is equal to CP, we already know because we proved that this triangle is congruent to this triangle. So we already have BP is equal to CP. And in one other triangle, we proved that this angle is equal to this angle. from the congruency of the two triangles, these two triangles, we know that this angle is equal to this angle. That is, angle 5 is equal to angle 6. Angle 5 is equal to angle 6. See here, these two triangles, ABP, ACP. ABP, this triangle. We proved that this one is congruent to ACP. Okay, so from this we have BP is equal to CP, CP, CTC. So AP bisects BC. Then we proved that this, from the congruency of these two triangles, we have this angle equal to this angle. That is, angle 5 is equal to angle 6. But 5 and 6 form a linear pair. Angle 5 is equal to angle 6. But angle 5 plus 6 is equal to 180. Linear pair. Because the two angles stand on a straight line. But since 5 is equal to 6, angle 5 plus angle 5 is equal to 180. Because 5 and 6 are equal. So instead of 6, you can say 5. So twice angle 5 is equal to 180. Angle 5 is equal to 90 degrees. If 5 is 90, 6 is also 90 because 5 and 6 are equal. If 5 is 90 degrees, 6 is also 90 degrees because 5 and 6 are equal. So 5 is 90, 6 is 90. That means AP is perpendicular to BC. AP is perpendicular to BC. So that's what you have here. See here. BP is equal to CP from the congruency of these two triangles. And angle 5 is equal to angle 6. This angle 5 is equal to angle 6 from the same two triangles, from the congruency of these two triangles. But 5 and 6 is equal, 5 plus 6 is equal to 180, linear pair axiom. So working that, you get angle 5 is 90. So I've marked this A. I've marked this A and this one is B. This is bisect. This is perpendicular. BP is equal to CP. BP is equal to CP means bisector. And 90 degrees means perpendicular. So from A and B, AP is the perpendicular bisector of BC. Please watch the recording again. And if you have any questions, you can ask me in the next class, because now I think you need to still process. You need to, if you've already understood in school, fine. Those who are learning this chapter for the first time, I'll not ask you if you have any doubts now, because you need to process whatever you've just heard. So for that, you need to go through the recording once again. You know, like revise the proof. Then only you will get doubts. Only when something is understood clearly, you have questions. So you can please mark and ask me in the next class, or you can even ask me on WhatsApp. So here, AD is an altitude. AD is an altitude of an isosceles triangle ABC. So again, ABC is an isosceles triangle with AB equal to AC is given. AD is the altitude. AD from A. So this is the altitude. Altitude means 90 degrees. Altitude means 90 degrees. AD is the altitude, meaning AD is perpendicular to BC. Show that AD bisects BC. Show that AD bisects BC. Bisects BC meaning you should show that BD is equal to CD. And AD bisects angle A. Bisects angle A. So show that angle 1 is equal to angle 2. So this is what you'll have to prove. You'll have to prove that BD is equal to DC. And you'll have to prove that angle 1 is equal to angle 2. Krishmika, can you try? Netra? Yes, Netra?
Ma'am.
Yeah. Tell me the two triangles.
ABD and ADC.
ADC. Tell me one side or one angle of the first triangle which is equal to an angle or side respectively of the second triangle. Yeah. Srijana, Arjun.
Ma'am, AD is equal to AD. It's common, ma'am.
Okay.
And AB is equal to AC.
Okay.
Ma'am?
Yeah.
Ma'am, can I, ma'am?
Yeah, tell me.
Ma'am, angle D is 90 degree on both sides, ma'am.
Correct. So we'll mark this angle 3 and angle 4.
Angle
So
3
angle,
is equal to angle 4, 90 degree, ma'am.
correct. So what is the rule?
Ma'am, right, RHS congruent rule, ma'am.
RHS. So this is right angle. Which is the hypotenuse?
Ma'am, AB equals to AC, hypotenuse.
This is the hypotenuse and this is some other side.
Yes, ma'am.
Because, yeah, this is the right angle. So this will be the hypotenuse. This will be the hypotenuse. Correct. So 3 is equal to 90 degrees because AD is perpendicular. AD is the altitude. So this is 90 degrees. So angle 3 is equal to angle 4, 90 degrees. Right angle. AB is equal to AC. Hypotenuse equal in both the triangles, H. And some other side, AD is equal to AD. So by RHS rule, it's not SHR, children. You can write it in this order. You can write it in this order, but it is RHS. It is RHS rule. By RHS congruence rule, the two triangles are congruent. So what is the order? How will you name the two triangles? If I say, Netra, if I say DAB, how will you name the other triangle?
Ma'am, D. One second. DAC, ma'am.
DAC. DAC. So from this, can you see that DB is equal to DC?
Yes, ma'am.
So DB is equal to DC, meaning? See here, DB is equal to DC. DB is equal to DC. That means AD bisects BC. And then how do you show that angle 1 is equal to 2? It's A in both the triangles. See here, angle A of the first triangle is equal to angle A of the second triangle. So that means angle 1 of the first triangle is equal to angle 2 of the second triangle. So since DB is equal to DC, AD bisects BC. And since angle 1 is equal to angle 2, AD bisects angle A. BC is bisected. That means cut into two equal pieces, DB and DC. If DB is equal to DC, that means AD bisects BC. See here, if this piece DB is equal to DC, that means BC is bisected. BC is bisected, cut into two equal pieces. And if angle A bisects angle A, if angle A is bisected, that means angle 1 should be equal to angle 2. So we have proved both the results. Angle 1 is equal to angle 2 and BD is equal to DC. Hence, we have proved these two. Yeah. So here also sometimes the figure will not be given, children. Here, two sides AB, BC and median AM of one triangle ABC are respectively equal to the sides PQ, QR and median a PN of triangle PQR. So we have triangle ABC and CF. We have triangle ABC and PQR. Okay, so we have triangle ABC and triangle PQR. PQR. See what is given. Two sides AB, BC, and the median AM of one triangle. Okay, let me write it. Let's take the whole, this figure itself. Let me write it here. Look at this figure itself, children. Look at the figure given in the question itself. I'll draw the figure for you. Let me tell you this first. Two sides AB, BC, and the median AM of one triangle are respectively equal to the sides PQ, QR, and median PN of triangle PQR. This is the information given. I'll tell you again. See here. Two sides AB. All this of one triangle. Now you'll understand. You'll ask me why you're writing it one below the other. All this of triangle ABC. See here. There is one triangle ABC. There's another triangle PQR. Okay. The sides AB, BC, and median AM of the triangle ABC are respectively equal to the sides PQ, QR, and median PN of triangle PQR. So this is the information given. With this given, you'll have to show 1 and 2. ABM congruent to PQN and ABC congruent to PQN. So there are two triangles ABC and triangle PQR. Two sides AB, BC and median AM of triangle ABC are respectively equal to the sides PQ, QR and median PN of this triangle PQR. So given this, we'll have to show that ABM is congruent to PQN. And ABC is congruent to PQN. Yeah, children. I think the diagram is also fine. So see a triangle ABC, triangle PQR, ABC, PQR. Median. AM is the median. AM is the median. Median meets the opposite side at the midpoint. PN is the median. Median need not be perpendicular to the side. Median meets the side at the midpoint. M is the midpoint of BC. Where is it given? It's not given, but because AM is the median, M will be the midpoint of BC. Since PN is the median, N is the midpoint of QR. AM is the median of triangle ABC. That means M is the midpoint of BC. P altitude means right angle. Median means midpoint. M is the midpoint of BC, N is the midpoint of QR because AM and PN are the medians. Okay, so AB is equal to PQ, BC, this full side BC, okay, I can mark it only here, but the full side BC is equal to the side QR and the median AM is equal to the median PN. Now, how do we show that ABM How do you show that these two triangles are congruent? ABM and PQN.
Ma'am, can I?
Yes. Sindhu, is it?
Yes, ma'am.
Yeah.
Ma'am, AB is equal to PQ.
1 minute. Name the triangle, Sindhu.
Ma'am, triangle ABM and triangle PQN, ma'am.
Okay.
AB is equal to PQ given, ma'am.
Okay.
And BM is equal to QN given, ma'am.
No, it's not given. BM is equal to QN is not given. BC is equal to QR is given. I told you while marking. This is BC equal to QR. We can see in the question, BC is only equal to QR.
Ma'am, AM is equal to PN, ma'am.
Correct. AM is equal to PN is correct. One more information.
Ma'am, BN is equal
Ma'am,
to
BC is equal to QR, ma'am.
But that's not a valid information, no, because BC is not a side of ABM. BC is equal to QR, but BC is not a side of ABM. See here, AB, what are the sides of ABM? AB, BM, AM. And the sides of PQN, PQ, QN, PN. So BC is equal to QR is correct, it's given. But that's not relevant to these two triangles.
Ma'am, BC equals to QR, half of BC equals to half of QR, BM equals to QN, ma'am.
Correct. So BC is equal to QR given. Half of BC will be equal to half of QR. Now, why are we taking half? Because we know the midpoint. So now what is half of BC? What is half of BC? You can write BM or CM. Half of BC is BM or CM. But we'll write BM because that is relevant to triangle ABM. And half of QR is QN or RN.
QN.
But we'll write QN because that is relevant to triangle PQN. So this is what you should write. BC is equal to QR given. Half of BC is equal to half of QR. Now, when you say half of BC, since M is the midpoint, AM is the median, this is the midpoint. So what will be half of BC? What will be half of BC? It is either BM or CM, anything you can write. And again here, PN is the median, N is the midpoint, N is the midpoint. So QN is equal to RN. So half of BC is BM and half of QR is QN, or half of BC is also this one. Half of QR is also this one. But since we have to write information relevant to these two triangles, we'll write BM and QN. So that's what is the third information. BM is equal to QN. BM. So by what rule the triangles are congruent?
Yes, ma'am.
Yes, ma'am.
SSS rule, the triangles are congruent. So now that the triangles are congruent, now in these two triangles, we have all the three, the three sides of one triangle equal to the corresponding three sides of the other triangle. So what are the other information we can get from the congruency of these two triangles?
Angle A is equals to angle B, ma'am.
Angle A is equal to angle
P, ma'am.
P. So that means this one, this angle is equal to this angle, correct?
Yes, ma'am. Angle
Yeah,
B,
then
angle Q, ma'am.
1 second. So angle A is equal to angle P. Then angle B is equal to angle Q. So which is B? Angle B, this one, this is angle B, is equal to angle Q. This angle is equal to this angle. Then angle
M is equal to angle
M is equals to angle N, ma'am.
M is equal to angle N. See, when we say M and N, M is this one. M is this one of this triangle and N is this one of this triangle. So M is equal to N. So it's this angle. This angle equal to this angle. So if we want, we can use this while proving that these two triangles are congruent. Supposing we don't have sufficient information, we can use this. You can take this angle is equal to this angle. Meaning, see, I'm just telling you, this angle is equal to this angle, or you can take this angle is equal to this angle, or this angle is equal to this angle. If it will help you, you can take all that. Yeah, now tell me in triangle ABC and triangle PQR.
Ma'am, shall I?
Yeah, Danya.
Ma'am, so in both the triangles, AB is equal to PQ, ma'am.
Okay. Reason
It's given, ma'am.
given. Okay.
And BC is equal to QR, ma'am. It is also
BC is-
given because AM is the median, ma'am.
And then third one.
And third one is angle ABM is equal to angle PQN. That is angle B is equal to angle Q. Because of we have already proved, ma'am.
Correct. So this angle is equal to this angle. Now, why can't we write, Danya, why can't we write AM is equal to PN?
Ma'am, it's not in the triangle, no, ma'am. Only we have taken only triangle ABC and PQN.
Yeah. Now tell me the sides of this triangle.
AB, BC, and AC.
So we don't get AM there.
Yes, ma'am.
Tell me the sides of this triangle.
PQ and RQ and RP.
PQ, QR, PR. Correct. So we don't get PN there. So this information is true, but it's not relevant to these two triangles. This information is true, but it's not relevant to these two triangles. So we can't write this. So as Danya said, this angle is equal to this angle from the congruency of these two triangles. So we have to write angle ABN is equal to angle PQN. So what's the rule, Danya?
Ma'am, so by SAS congruency, triangle ABC is congruent to triangle PQR.
Correct. SAS rule. SAS rule, the two triangles are congruent. Very good. Yeah, I'll just give you some time. Go through this proof on the slide. So I request you to, if you feel it's not very clear, don't worry, children. Go through the recording. I can make a separate session for those who have, a few or many doubts in this chapter. I'm not going to go to the extra sums now. I just want to make sure that all of you have understood, whatever we have done so far from NCERT clearly. Only then I can go ahead with the extra problems. So I'll give those of you who are clear with the chapter, good. Others, please watch the recordings. Watch the initial recordings. Watch the initial recordings. And I'll give you 1 day time, that is Thursday. Saturday, we'll continue with the extra problems. Saturday, we'll continue with the extra problems outside NCERT. So before that, you get your doubts clarified. All right. So with this, we finish meaning congruent triangles from NCERT. So I was telling you in the last class that we'll take the introduction to Heron's formula. So next class, we'll be working questions from this chapter, Heron's formula. So we'll be doing both, congruent triangles, extra proofs, and Heron's formula simultaneously. All right, children. So you have come across all these formulas so far. You know that to find the area of a triangle, you can use the formula half base into height, half base into corresponding altitude, half into base into corresponding altitude, all square units, area, so square units. So area of a triangle is equal to half base into height, half base into corresponding altitude. Okay. If it's a right triangle, half product of legs, half product of legs. The legs are, see, this is the hypotenuse. This is the hypotenuse. Leave that. This is one leg. This is the other leg. The legs are the sides containing the right angle. In a right triangle, the legs are the sides containing the right angle, or the arms of the right angle. So this is one arm of the right angle. This is the other arm of the right angle. This is the right angle. These are the two arms. These are the two arms of the right angle. Those two arms, which are the sides, are called the legs of the right triangle. So in other words, one side is the hypotenuse. Leave that. The remaining two sides are called the legs of the right triangle. So area of a right triangle is equal to half product of legs. It's the same as half base into height. So if you say this is the base and this is the height, half product of legs meaning half into base into height. It's the same thing. Base into height is referred to as product of legs. Base into height is referred to as product of legs. Product meaning multiplication. Product of legs. This side into this side. This leg into this leg. Half into this leg into this leg. So area of a right triangle is equal to half into product of legs, square units. Otherwise, you know, area of a triangle is equal to half base into height, square units. Area of an equilateral triangle is equal to √3/4 into side square. √3/4 into, in an equilateral triangle, all the three sides are equal. So whatever is the length of the side, so √3/4 into side square units. Yeah, if you've forgotten these, please make a note. All square units, please make a note. Give the heading Heron's formula. Done?
Yes, ma'am.
All right. All of you?
Yes, ma'am.
I'm doing, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Now, what is this Heron's formula? So Heron's formula is used to find the area of a triangle, the area of a triangle when the lengths of the three sides are given, are known. So in a triangle, any triangle, you can find, using Heron's formula, you can find the area of any triangle. It can be a right triangle, it can be equilateral, anything, any triangle. Now equilateral triangle, you already have a formula, √3/4 into side square. Supposing you forget that and you use Heron's formula, you will get the same answer. You can apply this formula to any triangle, whether it is isosceles, equilateral, right triangle, whatever kind of triangle it is. Supposing you can find the area of a triangle using half base into height. Say that you just forgot and you know the three sides, so you use the Heron's formula and you find its area. You will get the same answer as you would get when you use half base into height. The answer will not change. The answer has to be the same because one triangle has only one area. You cannot get different values when you use different formula for the same triangle. So Heron's formula, now √3/4 into side square can be used only for an equilateral triangle. Only for an equilateral triangle. Heron's formula can be used to find the area of any triangle when the lengths of the three sides are known. So when you know only the length of the three sides, supposing this is 10, this is 12, and say this is 15. Now you cannot use the formula half base into height here. You cannot use the formula half base into height because half into, you know, base you can take 10, 12 or 15. Base you can take 10, 12 or 15, but you don't know the corresponding altitudes. You do not know the altitude on this side. You don't know this altitude. You don't know this altitude. You don't know this altitude. See, every side has a corresponding altitude, right? Every side has a corresponding altitude. If you take 10 as the base, you must know the length of the corresponding altitude, this one. You must know the length of this one. You must know the length of the corresponding altitude. This is the corresponding altitude. If you use 12 as the base, you should know the length of the corresponding altitude, this one. You should know the length of this altitude, corresponding altitude. If you take 15 as the base, you should know the length of the corresponding altitude, this one. So which one to take as the base? Any one of the three sides of the triangle. Any one of the three sides of the triangle can be taken as the base. Any one of the three sides, you can take 10 as the base, 12 as the base, 15 as the base. Anything can be taken as the base, but you must use the corresponding altitude. You cannot use now, for example, 10, 12 and 15, and supposing this height is given, okay, this height says given, say like some 13 centimeters. You cannot say half into base is 12 and altitude is 13. This is wrong. If you take 12 as the base, you should know the length of this altitude. So here half into, you have to take 10 as the base because you know the altitude on the side 10 centimeters, which is 13. You cannot say half into base is 12 and altitude is 13 because 13 is not the altitude. 13 is the altitude on this side, 13 is the length of the altitude on this side. So you must take 10 as the base, then 13 will be the altitude. You cannot take 12 as the base and 13 as the altitude because 13 is the altitude on some other side, not on the side which is 12 centimeters. So in this triangle, I'll write this again. Don't worry, I'll write it again. So in our example, 10, I think I wrote 12 and 15 here. If you know that this is 13, supposing you know this is 13 centimeters, area of this triangle is half into base 10 only you should take into corresponding height 13. Into corresponding height 13. Supposing you know this altitude, then you should take half into base. Supposing this is 8. So half into base is 15 into height 8. Base can be any side. Altitude should be the corresponding altitude. If you take 15 as the base, then 8 is the altitude. You cannot say half into base is 12 and 8 is the altitude. 8 is not the altitude on the base 12 centimeters. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
All right. So when do we use Heron's formula? Heron's formula is used to find the area of a triangle when the lengths of the three sides are known, are given or known, whatever, are known or are given. So if you have a triangle where this is 9 centimeters, this is 11, this is 13. Okay, now we cannot use the formula half base into height because we have base 9, 13, 11. We know 3 bases here, but we don't know the altitude on any base. Then we cannot find its area using the formula half base into height. To find the area of this triangle, whose sides are 9 centimeters, 11 centimeters, and 13 centimeters, we cannot use the formula half base into height because base we have 9 centimeters, 13 centimeters, 11 centimeters. We have the base, but we don't have their corresponding altitudes. So we cannot use this formula half base into height. In this situation, we can find the area of the triangle using Heron's formula. Area of the triangle using Heron's formula. In a situation where you have to find the area of a triangle, you know the lengths of only the three sides. You don't know their altitudes. In such a situation, you can use the Heron's formula to find the area of the triangle. Altitudes are not given. Only the three sides are known to you. And you have to find the area of the triangle. So this is when we use Heron's formula. Okay. So how do we find the, area of the triangle using Heron's formula? One minute, sorry. Yes, Chip. So the area of the formula to find the area of the triangle using Heron's formula is root of or square root of s into s minus a into s minus b into s minus c square units, where a, b, c are the sides, the lengths of the three sides of the triangle, and s is the semi-perimeter. We've heard the term perimeter. Perimeter is the sum of the three sides of the triangle, a plus b plus c. Perimeter of the triangle is a plus b plus c. Semi-perimeter meaning half of the perimeter. Semi-perimeter meaning half of the perimeter. So a plus b plus c by 2. Perimeter by 2. Semi-perimeter. Perimeter by 2. So the formula is, Heron's formula is root of s into s minus a into s minus b into s minus c square units, where a, b, c are the lengths of the three sides of the triangle, and s is the semi-perimeter. How do you find the value of s? A plus b plus c by 2. A, b, c will be given to you. The values of a, b, and c will be given to you. And the question will be to you find the area of the triangle. So since you only know the sides of the triangle, you do not know any of the altitudes, we can use the Heron's formula to find the area of the triangle. So first thing is you should find s. A plus b plus c by 2. Should get the value of s. A, b, c will be given in the question. Then you should find s using a plus b plus c by 2. Then substitute the values in the formula and find the area. All right, children?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yeah, finish writing this?
Writing, ma'am.
Yeah, please write. Yeah, please write. Done, children?
Completed, ma'am.
All right.
Completed, ma'am.
Yeah. Those who have not finished, just take a screenshot and complete it. All right, children. So we'll take up questions based on this formula in the next class. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.